Hello everyone, my name is Andrew. Today we'll continue learning Python and today we'll talk about password hashing. Why is it important, what it has to do with us, and why we need to consider it in every kind of application. So let's start. Password hashing. Imagine that we have a database where we store our users. For example, we have a database with, for example, one is an ID, I know Tom is the username, and then we have Tom's password. For example, it's my password 1. So what is the problem with that? And imagine that that is the row in the database. What is the problem with that? Well, the most obvious problem is that we store a password in a row form. What does it mean? If somebody can access our database, he or she can access all of the raw passwords that our user wrote on our website. And again, you may ask, what is the problem? Even if a hacker that will access your database will access it for like 1 minute, for 2 minutes, he can literally select all of the passwords and all of the users and then log in to each of their accounts. And because of that, we don't store raw passwords in any form. We store hashed passwords in our data sources. So what does it mean, hashed password? In cryptography, there is a hash function. What's a hash function? Hash function is a function, so it executes some computations on a string, typically on a string, on bytes, or on any kind of data. And after that, we get a brand new value that is completely random. What does it mean? It's not completely random, but I'll show it to you. So in Python, we have a hashlib library, and hashlib has not some, but most of hashing algorithms. So what is hashlib? Hashlib.md5, that's one of algorithms of hashing. And for example, let's write hello. So now, and we need to also write hex digest to receive a normal string. So again, what we did right here, we used a hash function, which is MD5. Again, there are a lot of hash functions. There are a lot of types of hash functions in programming cryptography in general. Today we'll talk about MD5, SHA-1, SHA-512, and some other functions. And I will tell you why most of the functions, hash functions, are not as secure as they used to be. So if you worked in any programming language, that you probably heard about MD5 hash function, because it's every beginner knows about MD5. So it's like a hash function for beginners, but there is a problem with that. But now let's talk about only why we need to store hash passwords. So as you can see, imagine that our user wrote my password 1 as his password. And now as you can see, when we hashed our password, so we put it inside of hash function, we received an output of that string. And that string is a hashed password. So what does it mean? Again, as you can see, two of those strings are completely different. And hash functions have some similarities between them. So the first are no similarities, but rather rules. That if you write in a hash function, you need to follow some sets of rules. So the first rule is that all of hash functions should change dramatically when you change your value in any way. So for example, if I change my value from my password 1, so let me just copy that hash result, and let me just write hello. Let's run it. As you can see, our hashed value changed dramatically. But there is also will be those drastic changes if I'll just change one, even if I'll not add anything, but I'll change, for example, hello to hello. Now let's run it again, and as you can see, they are completely different. They have some similarity. No, they don't have some similarities. The only similar thing between them is like 5 at the start of both of those hashes. So that is the first rule. When you put a value inside of a hash function, the output should be changed drastically. So you don't even understand what is the input, what was the input of that hash function, what was the input of that hash function, what are the results. We don't know. We know the results, but we don't know the inputs that our users or anybody gives to that hash function. So that is the first rule. The second rule is that does not matter what's the length of your object, you still receive the same length of your output. So for example, in Python, what we can do is multiply let's multiply by 100, multiply any byte object by 100. And let me just print it for you so you will see it. Let's run it. Yeah, as you can see, it's hello, 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 hello. And if I would use like the last line, which is our hash function, then you see that it has the same length as I think it's my password1 string has. So that is the second rule. Hash functions must return the same length. Does not matter how big or how small your value is. Even if I just put one, for example, 1a. So a, let's run it again, and let's copy that. Let's copy that. As you can see, the length is similar. In MD5 and SHA-1 functions, the length is 128 bytes, as far as I'm concerned. Yeah, 128 bytes for both of them. But what is the advantage when we are using hash functions? So you know that in cryptography, we basically do two things. We encrypt something and we decrypt something. However, with hash functions, we cannot decrypt the value. So what does that mean? That means that if we hashed a value, it will be very complex for us to receive the initial value. So that means that if I hash, for example, my password, so my password 1, let's run it again, my password 1, as you can see, that is the result. And then I save it in a database. There are two advantages. First of all, I cannot receive the raw password, so the initial password that our user decided to put into his account. And second of all, I cannot see the raw password even if I connect it to my database. So what does that mean? Imagine a manager, a very bad manager that wants to log into another user account. If you store raw passwords in your database, anyone who has access to your database, even the application itself, your application can log in into other users' accounts, so into any account. However, if you store hashes, then nobody can do that because you don't know the initial value. But you can ask, okay, so we don't know the initial value. How we can check for that initial value? How we can really check that if your user writes a password, it's the correct one? So how we can check that? We can simply compare the hashes. So if I run it again, so again, my password 1, let's copy it, and even if I will replace it, as you can see, it does not change. So that means that instead of comparing raw passwords, we can compare hashes of those passwords. And that is much better in terms of security, because now we don't compare raw passwords, we don't store them, and if a hacker receives some information from a database that contains some passwords, some other user information, hacker cannot access all of the user's accounts immediately. But there is a catch. What's the catch? Again, I need to repeat it that you always should store your passwords in a hashed way. So you always need to hash them. However, as I said, there are a lot of hash functions out there, and if we want to use the most secure one, we should forget about all of other functions. There is no like the most secure function, hash function right now. There are like bcrypt function, GL2 function, something like that. So there are a lot of functions, and you need to read about all of them. But as you can see, we used MD5. And what's the problem with hash functions? Like, okay, you can say we cannot receive the initial value. What's the problem? If we cannot receive the initial value, then even if our hacker can access our database, he cannot see the initial password. Thus, he cannot access all of the users. He cannot log in into user's account. So what's the problem? The problem is that if we use insecure hash function, okay, so what is insecure hash function? Imagine that you have value hello, and if you write value hello, you receive the hash of 40 symbols. As far as I'm concerned, it's 40. So yeah, maybe 40. I'm not sure. Maybe 40, maybe 42. So you receive that hash. Okay, that is the hash of hello, and you store it in the database. Okay, but if you use that string, the bigger string, you still receive the hash of the same length. What does that mean? That means that okay, let me do it like that again. As you can see, they are the same length. What does that mean? That means that if we have any kind of information and we will put it into the same length, so our length, output length should be the same, then probably we'll have a collision. So what is a collision in terms of hash? Collision is when two hashes collide with each other, so they have the same value. And why is that bad? That is bad because insecure hashes like MD5 or SHA-1 can be easily broken. So what do I mean by that? There are a lot of things, a lot of cracking methods that we can use. The most it's not useful, but the most reliable one is just to cycle through all of the passwords, and if the hashes match, then everything is okay. But it's like brute force, so we don't talk about that. Another way is a rainbow table. So what is that? Rainbow table, and let me just open up my browser, crackstation.net. Yeah, here it is. So we have crackstation.net website, and here we can hash or we can crack our hashes. As you can see, it says supports, and that is not the only website. There are a lot of those, but as you can see, it says supports MD5, and there is SHA-1 algorithms. So what does that mean? That means that if I want, or if I can copy that and put it right here, then press that I am not a robot, and then press crack hashes. Okay, as you can see, it's not found. That's really interesting. Okay, let me try a hash which is more like my password 1. Let's run it. Yeah, as you can see, now we received another hash. Let me try that one, because yeah, as you can see, now it says my password 1. So what happened here? The first hash that I put in that CrackStation website was the hash of not I think I had a tuple in one of my in my password, so I wrote my MA password, not my password, and therefore CrackStation could not find that hash. What do I mean by that? CrackStation has a big database of hashes and values that are connected, or which are the input of the hashes that are output of hash function. So I think you know what I mean. So we have a table of two things. First of all, the input and then the output. And what CrackStation does is literally just scans. Well, it not scans, there is a better algorithm called hashing. So yeah, it just uses hashes. I think, yeah, nothing. Okay, it uses hashes, not the hashes for the security, but well, those are the same, but there are two types of hashes, not two types of hashes, but we can use hashes in many situations. One of them is using dictionaries in Python. And if you know how dictionaries work, you know that they are really quick, because we don't look for the value, so we don't scan our whole container, but instead of that, we just get the hash, and if we found it, okay, we found it. And in Python, when we are talking about dictionaries, the speed of our algorithm, or the complexity of our algorithm, is all from 1. What does it mean? That we need to execute at worst one step in order to find our element in a dictionary, compared to list, for example, where we need to execute all from n steps. So we need to go through every element in the list, compare them, and that's really bad. So in terms of CrackStation, what it does, it has the same structure as dictionary. So it literally just spans all from 1. So we need only one step in order to find our hash. But as you saw, we cannot find all of the hashes. So if I'll change it to SHA-1, let me just show it to you. SHA-1, oh yeah, SHA-1. That's another hashing algorithm, and as you can see, it returns the different hash because of and the length of that hash is also different. But it does not break a rule, because ND5 and SHA-1 have nothing to do with each other. So yeah, hashes should be the same length in terms of one hashing algorithm. But as you can see, both of the hashes got hacked. So in our case, that hash is MD5, my password 1, that hash is SHA-1, my password 1. What does it tell us? That tells that first of all we should use other hash functions, because if we can crack those hashes, then it's really really easy for hackers to do it as well. And yeah, that's the first thing. Use secure hash functions. I will not talk about them in that video because, again, as I said, I'll have a new video series when you will be able to hack my programs, and yeah, you need to learn them yourselves. But you need to wait for that. Everything will be all the information will be in the near future. But what I want to tell you is that first of all, you should use secure hash functions. Probably you should go into some kind of backcrypt, maybe DGL2, or at least use SHA-512. So SHA-512, like that. And that algorithm is much more secure. Also, what you need to do is add salt. So I will not explain salt, why we need it, why it's important, but salt is just a value that you append to your password. So for example, hello or something like that. And again, that should be bytes as well. So we just append that value to our password, and after that we receive a brand new hash because our value changes. But there are some problems with salt, and many argue that we don't need, well, we need salt, but there are problems on how to store it, because salt is stored in database as well. Even if your hacker has access to your database, then he has access to your salt as well. But still, it's better than using no salt, because again, it mixes up your password, and hackers will not be as successful in their password cracking journey as they would be if we had no salt. So again, always use salt, but I will probably make another video on it, or you need to read it. You need to look for the information about salt yourself. Okay, so those are the two most important things. First of all, use secure hashing algorithm, and second of all, use salt. The third thing that is very important, but it's sometimes overlooked, is that what you need to do is ban your users from just putting very like, basic password, like my password 1. There should be no passwords on your program, application, website, whatever, that are very similar to other passwords on the internet. Because that way, if we don't have passwords that are very similar, for example, we have my password, let me just write it something like that. Okay, so we have that password, let's run it. Okay, so we received that hash as the result. Let me just put it right here, and let's crack our hashes. As you can see, it's unknown, so nothing was found, because our password, because CrackStation, and again, maybe other sites will find it, but CrackStation does not have that hash in its database, and therefore we cannot crack it as easily as we could with a password like my password 1. But still, CrackStation is not the perfect website. I just found it. I don't know how great it is, but yeah, it's pretty great. But there are there are a lot of there are a lot of better tools, if you want to crack your password. But again, it's illegal, so don't do that. Only in educational purposes, and only if you want to improve the security of your own applications. But yeah, those are the three most important things. First of all, always use hash function and use a secure one. Second of all, use a salt with your hash function. And third of all, never allow your users to put very broad, or not broad, but very very similar, very popular passwords as their passwords in your database. And fourth of all, what you need to forget about is never show your password to anyone. So in terms of when you have an API, you should never send a password anywhere. So the password is something that is stored only on your server. Nobody sees it. Because if hackers will see your hash, so your password hash, still they will be able to crack it, no matter what is the hash function that you're using. But if nobody will see it, even if you're using something like SHA-1 or MD5, but you should never do that again, because those algorithms are very basic and they have been hacked a lot of times. But if nobody sees your password, then they don't even know if you have a password, or if you using that hash function or another hash function, or if you're using hash at all. So never show your passwords to anyone. I think That's all I've got to say today. So thank you for watching and good luck.